No, I don't participate. We probably only get info, and then when you two don't sign,
Yeah.
percent.
You don't think they count?
Yeah.
Well, yeah. We had a meeting.
See, and
And he said,
if you don't sign it, then we are missing 10%. It's not
I know that's
clear.
I just said, where's Alvaro? There's no steps on this. Yeah, we have to walk to the mic now. We can get, oh, there is steps, okay. Did you go up the steps? I came up. I didn't know. See the steps. Exit stage right. Like do a header. Yeah. Should I say we're getting ready to start?
Yeah, we're getting ready to start.
And I want you to know I'm noting the people that aren't here that should be.
This is because me and AC had sort of a gentleman's bet going on how many would come. I said we'd be lucky for 20. AC thought 40. You're getting closer.
You're in the right place. You can bring your friends and family too. Well, Jeff's here, so I guess we can at least go through the note well. Okay.
All right. Okay, so this is the second session of the LSR working group. We have a shorter agenda this time. Let's do the agenda bashing first. Or just note well come first. Yeah, note well first. So this is the note well. Supposed to read it all. Basically, it means by participating in this meeting, you're making an IETF contribution. Okay. So we have a short, did you want to? Yeah. We have a shorter, well, I was going to give people a chance to complain about the agenda, but we have some Yang updates followed by a couple more presentations. And first up is Tony. Does anybody want to bash the agenda changes? No. Okay, good. That will work usually when I get your presentation.
All right, thank you. So this is a talk about our Yang model for dynamic flooding. Apparently Yang models are now required for everything, so we attempted to jump in and do one. Please note that both of us are Yang novices, so we have no idea what we're doing. Please be gentle. We're happy to fix whatever. Let's see, there's a link to the current draft. We are spinning it as fast as we can go, which is not very fast. We're trying to cover both OSPF and ISIS with this. We're modeling all of the new TLVs that we've added, all the config, and all of the user interface that we're dealing with. So some of us have to deal with open config, and when we bounced things around internally, we got criticized for using IETF-oriented models, and we're asked to provide open config models instead. And so you'll see in the comments that we try to support both IETF and open config at the same time, which is a trick. So I'm not going to go through all of this because it gets really boring very quickly. But basically, we tried to cover everything. This covers the dynamic flooding capability, sub-TLV to router capabilities. Relatively straightforward. The config stuff, all of the various knobs for the config are here. Enabling dynamic flooding is this object. And status information. So you can suck out everything that's going on. This gives you the list of paths that the system has learned from the area leader. So this is a list of topologies, so you can just see exactly what's going on in the dynamic flooding. And I think that's it. So any questions? Cool. Thank you.
AC Lynn, I just want to make a point that this is interesting. I didn't review it very much, but this is the first time we have both ISIS and OSPF Yang model in the same draft, which so it's new ground. But I mean, that's good because we have a flooding. The flooding draft has both of them.
Hello everyone, this is Yingzhen. I'm just gonna give a quick update about some Yang modules. So I'm gonna cover 9 drafts in 10 minutes. First of all, OSPF and ISIS base modules. After 5 years, the good news is both of them are finally in editor queues. Unfortunately, we have some dependencies on the BFD module, so we'll have to wait until a little bit to publish them. But the model is, both of them are pretty much done. And here are a list of active contributors. So during the last call process, we actually gone through several revisions and fixed all the issues. One major change we did is, in OSPF and ISS, we have those flags field. And we used to use this field to say, oh, one flag, another flag, but we figure out those things are not augmentable. So we change those from type bits to identity. This is one major change during the last call process. If you are interested, please take a look at the modules. Here, list some how it's done as an example. So really just change the type. So it's easier for augmentation later. So the modules can be augmented. And then the next two is both OSPF and ISS module for segment routing. With all the drafts related with OSPF and ISS protocols are being published. These two are in the pipeline to be published. So the plan is we will publish the base SR model in spring first, and then these two will follow. So this give you a last opportunity to review them and comments if you have any, please. So the changes we've done so far, both of these models have been stable for some time. So the change we've done so far is basically just change everything to match what we've done in the base OSPF and the ISS model. And we expect to publish these two very soon. And we have two new working group documents.
Excuse me, Yingzhen, did you want to talk a little bit about that meeting we had with SRV6 Yang model offers on the last slide?
Sure.
Yeah.
So that's about the OSPF and the ISS SR module, because these two are augmenting the segment routing base module. And this week, the authors of the segment routing MPRS module had a meeting with the SRV6 module authors, and we make sure we align our configurations and also some common definitions. So then we can progress the base module. We make sure everything is aligned, and then we can, next step will be progress the protocol specific module. We will start we'll make one more changes, make the alignment, and we'll request the base module last call in spring. So the new working group document, the OSPF v3 extended LSA. This one is actually very important because all the new OSPF v3 features will have a dependency on this module if they are using the new extended LSA format. And the plan is to progress this one once we're done with the base OSPF module. And then we have the OSPF Yang augmentation version 1. So this one is, right now we have, I think, 4 modules included. This time we added the new OSPF v3 TE module, and we also have other modules included. This one, so far, I think the plan is to keep these 4 modules in this one document. If there are more features that need to be augmented to OSPF later, we will do another augmentation document, probably called version 2, just to keep all the modules up to date. This is a new document. It's OSPF v3 segment routing Yang. It's for the OSPF v3, but for segment routing MPRS feature. This one augment the base OSPF segment routing data module, and included all those TLVs. So people who are interested in implementing this feature, please take a look. We didn't have this in the base segment routing module because this one needs the OSPF v3 extended LSA. So we'll need to progress that one first and then this one. Okay, so we the OSPF augmentation modules we introduced, we started last IETF, and this IETF is already a working group document. And this one is a new one we are doing for ISS. We are doing the same activities for ISS. So this page listed all the RFCs published in ISS since 2016. Right now, this draft only has the minimum remaining lifetime included in this module. And Chris has another one he will present later. The reverse metric, Chris will present later. That's in a separate document. And we'll keep, next time, next revision, we'll probably consider adding the multi-instance support. And if you see any ISS feature that's not covered yet, please let us know. And if you need it, we'll add it. So for this module that we have so far in the document, is just the minimum remaining lifetime. It's covered RFC 7987. It's a very simple one. Please take a look and send us your comments if there is any. So far, it only has like a notification to say there's something you need to report. Okay, so the next one, the very last one, is the data model for ISS SRv6. So the SRv6 ISS document is already a working group document, and this one defines the YANG module for that document. It defines the configuration, how to do the locator siting, and how to also include the faster rerouting features, etc. Please review it and send us your comments. And the next step for this one, we'd like to request working group adoption for this draft. And that's it.
Hi, Alora Tharwaledi. I have a question for the chairs, actually. Do we have a YANG module augmentation plan? Or
It's coming together. Like, yeah, I had like done like the reverse metric one before. We sort of agreed to try to do this in bunches, which is where these augmentation version 1 things came from. Yeah, so it's, you know, that's what we're looking at now. But, you know, you also see that there's other modules there, you know, that aren't included in that. So I think we're sort of just, we're learning, right? It's a work in progress and trying to figure out what the best ways to do this are. You know, personally, I wasn't a fan. I don't know if this is with my chair hat on or I'm my member, working group member hat, but I wasn't a big fan of the augmented, but, you know, but other people seem to like that idea. So I was willing to go with the flow on that. Yeah, you're grabbing the mic. Go ahead.
Yeah. ACLM, yeah, we're not, I don't know, we're not in complete agreement. I'm hoping to get it all done, and I did not want to say, because it didn't work for SNMP. And I don't see why it would work that much better. Well, YANG is a lot easier to augment, but I meant was to make anybody who did a draft also do the YANG augmentations right in that draft. That's the idealistic approach. We haven't taken that to put such a barrier on drafts. We can discuss that for future functions, but because we have people that are contributing that don't know YANG, and now we have So separate, so we are, so for better or worse, right now we're doing separate drafts unless we change that with augmentations.
Okay, so what I'm getting from you guys is that we have those augmentation drafts, which may group several features, but in reality, as a working group, we are going to do whatever.
So that's what I was going to say is that this is our first shot at this, right? We're trying it out. I mean, I don't think there's any danger in doing it sort of both ways and figuring out which works better. I mean, my general thinking is that certainly for complex features, you know, it makes more sense to have a standalone draft, right? Because you know, I think of what I thought about the augmentation, the augmented model was that just picking up all these little bits here and there that got left out of the base model, right? I still think it makes sense to have a separate draft. Like if you have a major feature, you know, either as AC said, it might be hard to put it in the same draft, but if you're not going to put it in the same draft, to have a standalone pairing with it, right? Like a sister draft or something.
Chris Bowers with Juniper. Perhaps a reasonable compromise would be something like, you know, they can be in separate drafts. New feature and Yang model for new feature, separate drafts, you know, different expertise, but you know, maybe a requirement of working group last call is that at least the Yang model is at a level that it's adopted as a working group document. Some kind of staged approach that could make everyone happy.
I as a working group member, that sounds reasonable to me. You know, I mean, because you're not blocking it going forward. You're saying at least you've made some progress on this other one too.
Yeah, yeah.
We'd like to solicit other opinions on the list. Speaking as a working group member, I think that's reasonable to expect that.
See, for my personal opinion, I think if it's a large feature, we don't want the Yang module to delay the publication of that draft or RFC. So if it's a small feature, it will make more sense if it's possible to include the Yang module in the same draft. If you don't know how to do it, you can ask any of us for help. We will be happy to provide the Yang module.
So speaking as a working group member, last time this came around, I thought that we could have a you know, sort of a localized Yang doctor, you know, or Yang experts in the LSR group. You know, the problem is these author lists get so big, but you know, these things aren't hard to write for people that have written them. And you know, if you're working on, if there was a group of people you could go to and say, hey, you know, we're authoring this draft, would you like to join as an author to put the Yang stuff in there, right? I mean, it shouldn't be hard to do that, but you know, this is just brainstorming on my part on like how we might do that.
Right. So the reason I was asking is because maybe I had missed the discussion and there was already some plan. But I think that it's important that we discuss, and if we get to a conclusion of requiring or not or whatever it is, that way we know. And if there's you know, no specific plan, you know, it's good to know that there's no specific plan too, right? It is not a requirement that we have a plan. But if we need to discuss something, it would be important for it to be discussed on the list. Yes. Thank you.
Yeah, I just have one more thing. I think we're, with our Yang models of this, especially Yang models of this significance, this size as the LSR, I think we're ahead of most of the other working groups. So what we do might, you know, be a harbinger for other working groups in the routing area.
Thank you.
Thanks.
Your next list.
No, I'm going to do that. I got to remember to make a comment. Not have this be a pop-up. Right? It'd be nice to be able to go back.
Yeah, but keep
Keep it in a tab.
Tab, yeah.
Oh, no. Uh-oh. So what do we do? Pull it up on my laptop, right?
Yeah.
Okay, well, why don't we,
See if we can bring Leslie's up.
yeah, let me see if I can bring the next one up. This is it just me that has this particularly bad luck with this thing? Okay, Les. Thank you for going next.
Okay, I'm Les Ginsberg. At the last IETF, we had a couple of presentations talking about issues associated with increasing the rate of flooding. And since there were two different points of view that were presented, since that time, myself and my co-authors have issued this draft. There's also another draft that was authored by Bruno and several others. Okay. So going back to the base specification, this is what 10589 says about flooding. And the key takeaway here is that flooding was intended to be an interface independent parameter. There are some special considerations that were done for broadcast, and it's kind of the one that everybody remembers, where 10589 said roughly 33 milliseconds between sending LSPs on a broadcast interface. But 10589 did not actually specify this for point-to-point interfaces. But most implementations today have applied this to all interfaces. Why is, obviously 33 milliseconds, roughly 33 LSPs per second on a particular interface. It's relatively slow, or significantly slow by today's standards. And if you have a large network, and you're now talking about, you know, for example, if you have a node that has hundreds or 1,000 neighbors, and that node goes down, that means you've got 1,000 LSPs that have to be flooded network-wide. Well, you do the math, and if you're rate limited to 33 per second on an interface, it's going to take 30 seconds or more, which is a significant amount of time. So that's why we're all looking at what can we do to, what happens if we increase this rate significantly? What issues do we have to deal with? Convergence consists of a number of steps. One, the nodes that are adjacent to the topology change have to detect the topology change. They then update and flood their LSPs. As the LSPs are received on other nodes in the network, they run a new OSPF, and then you update the forwarding plane. Steps 2, 3, and 4 need to be done network-wide. So what we're the aim of flooding is really to get a consistent link state database network-wide as fast as possible. And this quote here from 10589 indicates how 10589 originally thought about this, and it was, well, at each interval, you look at all of the LSPs that still need to be sent, and you keep track of this on a per interface basis, and you send them all. Okay, the pacing interval that was associated with broadcast interfaces was never actually specified to be applied to point-to-point interfaces, but most implementations have done so. Clearly, if we're going to achieve convergence, one of the limiting factors is how quickly can we get the same link state database on every node in the network. So again, the goal of flooding in the abstract is let's do it as fast as possible. Why do we do pacing? Well, we have to deal with some real issues. There are other things being sent on an interface. There are other things that the router is doing. So we have to allow for the fact that there are other types of packets that need to be sent on the interface. And it's conceivable that, obviously processing an update to an LSP, just receiving it, getting it up to the control plane, having the protocol operate on it, takes time. And if you send them too fast, it's possible that you're going to overwhelm your neighbor. So let's talk about the consequences or the tools that we have to deal with faster flooding. This is just a little example of bandwidth is not a major consideration here. These are just numbers about what happens how much bandwidth do we consume if we go up to 100 per second or 1,000 per second. Flow control. So if I start sending LSPs to my neighbor at a much faster rate, it's possible due to whatever else my neighbor may be doing at that time, that there may be periods where he gets overwhelmed. If this happens occasionally, this is not a major issue. If this happens consistently, we've got a significant problem. What does it mean? It means maybe you've got a node of the network that is underpowered and simply can't deal with a network at the size that this particular network is. Or perhaps its configuration is such that it's doing more work than it should be doing. Or it needs to be in another position in the network where it doesn't have so many routes. There are various things that you could do. But this is not a state that is conducive to optimal operation of the network. As far as flow control is concerned, the position that we're presenting here, we already track, the base protocol update process already tracks for each LSP that's been updated. We keep track of the set of interfaces that we need to flood it on. Have we received an acknowledgement for that? So the update process is completely reliable. If you want to do flow control, it's easy enough to do flow control from the standpoint of the transmitter, because you can keep track of how many LSPs you have sent out on this particular interface that are still pending acknowledgement. So this is an algorithm that we've proposed for handling flow control. I'm not going to go through the details, but it's basically, if I have too many outstanding LSPs that haven't been acknowledged, I start to slow down. And so I don't overwhelm the neighbor. So that's flow control is one tool to deal with faster flooding. There's also packet prioritization. Most implementations today, or at least a number of them, have already prioritized receiving hellos over receiving SNPs and LSPs. Why do we do that? We do that because we don't want to if we get a burst of LSPs and that causes us to drop our adjacencies, that means we're going to have to generate even more LSPs. So it just exacerbates the problem. What we need to do here is to prioritize the reception of SNPs over LSPs, because SNPs provide the acknowledgement for LSPs. And if we drop SNPs, then potentially we're doing needless retransmissions of LSPs. We've already sent it to the neighbor, he's already received it, he's already acknowledged it, but we lost track of the fact that he acknowledged it. So this is another tool that we can use to help make using faster flooding operate more smoothly. Minimizing LSP generation. So ISIS is a TLV-based protocol. We have in the base specification up to 255 LSPs per, or 256 LSPs per level that can be generated by a given node. If I have, and I'll use the example here, I've got a bunch of neighbors and I've got them distributed into 3 different LSPs as I've shown here. If one of the neighbors goes down, I've got 2 strategies that I can use to update the LSPs to distribute this information to the rest of the network. With method number 1, so in this case, neighbor number 3 went down. Neighbor number 3 was in LSP 0. I simply remove neighbor number 3 from LSP 0 and I flood LSP 0. Method number 2, I decide, well, gee, now neighbor number 3 is gone. I can fit all of my neighbors into 2 LSPs, whereas before I needed 3 LSPs. So I'm going to shift everything and compact it. But when I do that, I pay a heavy price because now I've got to flood 3 LSPs. I've got to flood the update to LSP 0, the update to LSP 1, and I've got to purge LSP 2 that no longer has any content in it. This at scale, this exacerbates the flooding problem by an order of magnitude. And I think for those of us who have done implementations and dealt with scale, we've learned this lesson the hard way in some cases. So one of the lessons here is don't try to compact your LSPs unnecessarily. Try to minimize the number of LSPs that you need to update when a topology change occurs. Redundant flooding. There's a number of mechanisms available to reduce redundant flooding when you have a highly meshed network. One of them requires no protocol extensions whatsoever. You just make a local decision and say, I've got parallel links to the same neighbor. I don't need to flood this LSP update on all the links. I just want to make sure that each of my neighbors has received the update on at least one interface. We have mesh groups, which has been around for quite a few years. It's a bit laborious to deploy, but it is a tool that is available. And now we have the dynamic flooding draft. That's a working group document that allows us to calculate an optimal flooding topology. Jumbo frames. The unit of flooding for ISIS is an LSP. Traditionally, LSPs are limited to 1492 bytes because the maximum LSP size that you can send has to be less than the MTU of any interface in the network that is used for ISIS. Why is this true? Because ISIS does not support fragmentation. If you have a network that supports jumbo frames, you can increase the LSP MTU size to 4K, for example. This reduces the number of LSPs that each node generates and therefore reduces the number of LSPs that need to be sent when a topology change occurs, reduces the total size of the LSP database. So this is a summary of things that we can do to allow us to support a much faster flooding rate. Number one, I think we should be encouraging vendors to support faster flooding. This is clearly needed for networks at scale. We need to emphasize that the flooding rate is not a per interface parameter. The goal of flooding is to get things flooded as fast as we can network-wide, and not try to tune this to a particular neighbor. Use transmit-based flow control to make sure that we don't overwhelm the neighbors. Prioritize SNP reception, minimize LSP generation, reduce redundant flooding, and use jumbo frames when you can. The other comment I'd make before opening it up to questions or comments, we wrote this draft. It's intended to be an informational draft. As I said, there's a competing draft in the same space. We'll have to see where the discussion goes as far as the differences in the two drafts. I'm not totally convinced that at the end of the day we need a draft, regardless of what the consensus of the working group is. This could be something that it's good to have the discussion publicly. Whether we actually need to publish a standard, be it informational or standards track, I think is also something that the working group should consider. And that's it.
Bruno de Crane, Orange. So since you explicitly acknowledged that the discussion is related to draft the Crane flooding speed, so let's recap that the goal of that draft is about flooding, full point. So I think the problem is big enough and complex enough, and we don't need to look at independent or orthogonal points such as reducing redundant flooding. Yes, I agree. It's good. We have a working group document working on that, for example. I think it's orthogonal. I think it doesn't bring to put it in the discussion. Minimize the number of LSP generation. Yes, please, let's do that. Again, it's orthogonal. I think we should focus on flooding, which is already a big PowerPoint on which had a lot of discussion. And thank you for the chair for the big slot in Vancouver. It was really helpful. We also had many comments on the list. So I think we should focus on flooding. So what is flooding? I have a set of information that I need to send to you.
Mm-hmm.
That's all. I think we are in agreement that we want to do flooding as fast as possible. Are we?
Yes.
Okay,
yes.
Thank you. I think we are coming to an agreement that we are fine to do flow control per neighbor, that means per interface. Okay, so that's good. And so it's already a good improvement. If you can come to slide 4, I don't want to spend too much time on what we disagree. Okay, so that one is relevant to my comment. I think we should focus on what we're trying to do, which is flooding. I don't think bringing convergence in the discussion is helpful, and quite the contrary, I think it's harmful. It's a largely different subject, and if we talk about convergence, we are going to talk about packet loss. We are going to try to order the convergence in the network, but convergence is about updating the fib. It's very largely different about flooding. And it's important because for convergence, there was proposal a long time ago about ordered fib. And we can see that we would like for ordered fib, for convergence, to have an order within the network. And that could be beneficial to delay the order, depending on the type of topological change, okay? You know. But that's not what we want for flooding. For flooding, we don't want to delay the flooding. We don't want to order the flooding. We want to flood the information, and then with the information, we can try to do something intelligent for convergence, but I'd rather not discuss that subject at the same time. I don't think it's helpful. So with that, I'll leave to
yeah.
Tony.
So I think we're we're in total agreement here.
Okay.
I think that what we really want to discuss here is how can we flood as fast as possible.
Okay.
There are other tools in the toolkit to deal with convergence issues.
Yeah.
So we're in agreement.
So the points we are not fully in agreement, but we're going to work on it is doing flow control, so per neighbor or per interface.
Mhm.
And a priori, I think that doing some explicit flow control with your neighbor is safer and better. On that, we have a disagreement, but I'll leave that point to Tony.
I'll just say ditto and echo everything. So the only thing that I'd like to talk about is the precise algorithm. And I hope we agree that what we are trying to do when we say is flood as fast as possible is we are trying to maximize good put. Do we agree with that?
It's a qualified yes. I'm not sure where you're going next. That's the only reason I'm
Well,
stating.
do we agree that flooding as fast as possible does not mean dumping the entire LSDB as back-to-back packets?
Yes, we agree.
Okay, good. So we're trying to flood, maximize good put in getting a actual transfer between two nodes. And now this boils down to a control theory question, right? How can we maximize that good put? Now, because we are in a situation where we don't know the exact characteristics and their dynamic characteristics of the receiver, we have to make some estimates. And the question then becomes, how do we estimate what the receiver is doing? Your algorithm seems to depend on the lack of acknowledgements and uses no other information. The alternate proposal is to provide more information from the receiver that can give us more data about what the correct amount of throughput is.
So if we want to start talking about, the details, because this obviously is one of the points of difference between the two drafts, probably the most significant point of difference. We can do that. I don't know if do you want to have that discussion now?
I'm very happy to have that discussion now, or we can do it on the mailing list. I don't care.
Okay. The points I would make in regards to the receiver-based flow control that's in the draft you've co-authored are two things. One, I think what you've proposed is that the receiver be able to signal his neighbor, here's what I could handle, or, please slow down, or some kind of message to that effect, which requires signaling from the data plane to the control plane about the queue size, if you will, on a per interface basis of a particular set of protocol packets. I find that very challenging for any platform to implement. So from a practical standpoint, I'm very concerned that even if we could agree that this is, the best solution, I don't know how practical it is to implement. The second point I would make is the time when you need the signaling is when you're actually overloaded. And that's the time it requires, sending another hello back to your neighbor to say, hey, slow down. And that's the very time when you're more likely to be dropping packets. So I'm also concerned about that.
To your first question, so I had a little chat with a number of our hardware people, and as you know, we're mostly based on merchant silicon. It turns out that actually looking at the queue lengths coming up to the CPU is actually quite trivial. It is a register read.
Yes, but you're talking about for a particular protocol. There are many packets that are punted from data plane to forwarding or to control plane. It's not just ISI's packets, and we're not talking here about hellos. We're talking specifically about LSPs. So, I mean, there's a lot of detail here in terms of the information that has to go from the forwarding plane or the data plane to the control plane.
Exactly part of the problem.
Yeah.
So some implementations have been able to segregate packets to a very, very fine-grained detail. Okay, so some implementations have been able to separate LSPs from IAHs, for example. Some implementations do not. Okay, we need to kind of support both. Fortunately, the good news is that an implementation knows whether it has got that level of segmentation or not, and can report on the relevant queue regardless of how much that segmentation is happening.
Okay, but you're
So
proposing.
can I ask a question with my chair hat on? Is there, you don't like their proposal, but can't your proposal and their proposal actually live together? I'm basically going off what Tony just said. You know, if it's very easy, given your hardware, to determine packet types in your queue, right, and to be able to get the information needed, then that's easy to implement. If not, then couldn't they fall back to your proposal? I'm just wondering.
Obviously, if you can't provide the information, you can't. So yes, falling back to that proposal is a fine thing, right? It's better than where we are today.
Okay,
But
so-
I mean, they would live together. You're not going to get into some kind of weird oscillation.
And we would need that for backward compatibility anyway.
Well, so Chris, if I understand you correctly, what you're suggesting is that we define a transmit-based flow control, which everybody can implement. And for those implementations that can support the detection of the received queue length and send that, they can use the extensions that are defined in the other draft, which are then become optional. And then you have to define what happens when you're using, if you're going to use the transmit-based flow control by default, and if you happen to get the receiver-based, how do you decide how they interact? I suppose that's possible.
It seems like a reasonable compromise. To your second point, we never want to get into a situation where the receiver is congested. Regardless of what's going on, we never want to get to the point where our receive queue has 0 free entries. That means we're going to start dropping packets, and that's guaranteed to hurt goodput. So what we know is that we want the transmitter to keep that queue somewhat full, right? We always want to have work available for the CPU because we can't be guaranteed of getting about the rate exactly right, but we never want that queue to fill up because then we are overrunning, congesting, and wasting work. Do you agree with that?
I'm after what's practical here. Okay, I think we both have the same goal. I'm not totally convinced that the receiver side flow control is practical.
Well, let me ask you this. If I could tell you that I could receive 1 LSP per millisecond, could you do that for me?
Well, so, part of what we're talking about here is the goal is to flood the set of LSP changes network-wide, quote unquote, as fast as possible. Okay? Yeah, I would submit in most cases, there's no need to, flow control won't actually kick in. There are obviously some cases where, we get a large number of LSPs and it may kick in. But I think in general, we probably don't have to pace LSPs for 95% of the topology changes. So if I've got 3 LSPs to send, are you telling me I need to pace them at the interval that we've somehow decided whether it's sent from the receiver or imposed at the transmitter? Or are you suggesting only when I get to 500 or whatever the magic number is?
So I certainly agree that this is most important when there is a significant LSDB change.
So Am I? Is there something I haven't responded to yet? You're looking like it's my turn.
So if a receiver could specify a rate, what's the problem with complying with that?
So I think that this goes back to my concern that I think it's very difficult for the receiver to specify a rate. I mean, it's even, as I've expressed, I think it's difficult for a receiver even to detect the peak conditions and communicate them to the control plane when it's needed to do so. Trying to pre-calculate, here I am, everything's quiet, I'm looking at my configuration, I'm looking at the size of my LSP DB, I'm looking at all of the other protocols that are running, all of the other features are running. Somehow I'm supposed to figure out how many ISIS LSPs I can support on a particular interface. I think that's a pretty complex problem.
I think that's actually relatively easy to solve empirically. Given a given platform with a given queue depth and given CPU, it seems like a simple test would show quickly how many LSPs you could absorb.
If ISIS was the only thing running on the box that used that queue, then I think we could agree. But there's countless things that use that same queue.
Well, it should not be countless.
Well, I'm exaggerating for effect.
Hopefully there is some separation in this day and age, otherwise you're subject to DOS attacks. But given that there is some clear queue depth, then there's certainly a rate that should not be exceeded. And that's useful information to the transmitter.
Well, all right. I guess the point that we're not in consensus on is I think the problem is more complex. And in order to make sure that you don't get overflow, you're going to be overly conservative in what you advertise to your neighbor. That's my concern.
Say you're taking
Go ahead. It's Peter from Cisco. I just want to make the comment that on the distributed system, there's no single queue to monitor. You have queue on a line card, you have queue between a line card and RP, you have queue on a RP. We're going to look at all these queues. And as you said, Les, I mean, these queues are not just for us, they are shared with other traffic. I don't see a simple way how we can figure out the rate that we can receive.
AC Linda speaking as working group member. As just a point of reference, we looked at this. We had lots of problems with earlier OSPF implementations, and in the early 2000s, a guy from AT&T Research published a draft RFC 42222, and we did not, because of these complexities, we made a number of recommendations, but they didn't involve explicit per neighbor or per interface flow control. And since implementations have done that, the problems have pretty much gone away in OSPF.
I can't help but think about Hank's proposal. Was it last IETF or the one before, just doing it over TCP? I mean,
I think you're introducing a whole other set of issues that need to be discussed. So
yeah, I'm thinking about saying we don't know what rate to send, and then we've got convergence, and or not convergence, but yeah, we don't know what rate is optimal.
I like the way that AC, as a individual contributor, got up and spoke at the mic, as opposed to, was that an individual contributor comment?
Yeah, I think he did that because he's on the draft, right?
Okay, but even otherwise, I think that's actually a pretty good practice.
So do I need to walk all the way down there to do it?
No, but that mic is actually a good mic as well as a substitute.
But then I'm on camera as a presenter.
Yeah. Anyways, I think that would actually help a lot. So Chris Bowers, I just had a comment about, when I originally worked on the draft with Bruno, the idea was that I had in mind wasn't the dynamic adjustment of this received value. And I believe there's still text in the draft that talks about that. So a fallback, even if you don't believe you're able to, for whatever reason, compute dynamically what your maximum receive rate should be, by advertising no value, by saying we just can't advertise any value, we're really putting it back on the service providers to individually test every single hardware platform and software release and vendor and set the value themselves. And I think we can possibly do a little better than that. They are using extremely conservative values now. A value that says, look, I'm on a really, a method that says I'm on a really, limited platform. I'm going to, use this current value, like 33 milliseconds or something. I'm on a stronger platform in general, and I figure out I have, only 10 interfaces. Then I'm going to go, well, it's probably okay for me to go down to 5 milliseconds. Something along those lines, and that value doesn't change over time. It's like a, changes maybe as you change configuration and number of interfaces. That seems like a reasonable, advertised value. It could be, it doesn't need to be in a TLV per se, but it makes deployment of this so much easier for service providers. That's my
So just
take.
a quick question, if I can put you on the spot instead of me. So what do you do when, for example, they enable another protocol, or they extend the operation of another protocol, which is also going to consume some of the same resources?
Yeah, the estimate that you would probably want to be using for this, the value, this static value, should assume, okay, you've got sort of a maximum amount of BGP going on or whatever.
Mm-hmm.
But again, that we do that testing and be willing to, publish that value in a TLV, at least in some scenario, is better than the current situation where they're choosing the worst conservative values.
Yeah.
So-
In fact, in my experience, I want to reinforce what you're saying, because in my experience, nobody tunes these values. The vendor, has them, and they're all kind of the same order of magnitude. And
Correct.
Nobody messes
So
with
if we
it.
want people to be able to lower them,
Yeah.
then we have to be willing to say, okay, at the very least, this value is reasonably safe. Now, your flow control mechanism of, not hacking the SNMPs could then kick in, for example. But at least being willing to advertise some information now so that we can at least get below the values that have been in the network for 10 years or 20 years is, statically, in a relatively static manner would be quite useful.
So I think we obviously all have the same goal. We all think flooding is much slower than it needs to be, and we want to be more aggressive. I think all we're trying to debate is what's the safest way to do that, I think.
Oh, good. I was going to say we probably have to move on to the next presentation, but it looks like we're done with the discussion. Perfect.
Yeah. We had some more time on the agenda today, some slack time, so we let that discussion go. We won't be able to do that for every presentation.
Okay. It worked every time.
Here's in the middle. Okay.
What's that? Is this the right one?
Yeah, that's right.
I'll wait and see.
Hello. Here we just make a presentation for the prefix unreachable announcement. The scenario will introduce the scenario and the solution and for actions. We will introduce three scenarios. The first scenario is for inter-area. You know, normally for inter-area design, we will often make the summary address at the border router. But if the border router make a summary address and the one node in one area have been failure, the node in other area will be notified immediately. It will depend on the other mechanism to detect the failure of the node. So this phenomena, I think it exists in the IPv4 network, but it will be exacerbated for the in the future for the IPv6 or SIV6 deployment. Another scenario is also for the inter-area. This is for the link failure. You know, in previous scenario, it is node failure. In second scenario, it is link failure. So if there are two links that connect one node being disconnected, then one of the ABR router, for example, in IR2, can't reach out to the node T2, but because it still advertises the summary address, then our node will still think that it can reach the unreachable node. So the traffic to the T2 in this example will be dropped by the R2. The traffic should be rerouted through the other ABR route, but you know, in current situation, there is no solution to avoid this situation. The third scenario is for the intra area. You know, in this area, the backbone area, for example, area 0, also do some summary address. This summary address covers the address of the node's prefix. So if the node get failure, even if it is in the same area, the other node receive the summary address that cover the field node's prefix. So it will still think the field node will be reached. So some other backup path, for example, the SRv6 backup will cannot bypass the field node. This is the scenario for the prefix unreachable. Based on the scenario, we have proposed some solution. The first is for the interior unreachable solution. In this, because we know for OSPF and for IS, we have defined the prefix originator TLV. So we want to use this TLV or use this information to notify the other router in other area that one prefix is unreachable. For example, in this graph, if the node T2 failed, it will be detected by the ABR router R2 and R4. The ABR router R2 and R4 will announce not only the summary address but also the prefix unreachable announcement. We abbreviated the PUA LSA. This address this LSA will be flooded to other areas. So when the receiver in other area receive this LSA, it will generate one black hole route that it is said it cannot reach the field node. There are some conditions to describe the condition for generating the PUA and the action on the PUA. Another solution is for the intra area. Where we have introduced for intra area, there are also some situations the summary that will cover the field node or field link prefix. So in such situation, we want to the if the node within the area receive the this information, it will and find the field node is falling within the scope of the summary address. It also will generate automatically with the black hole route to the field node or field links. Such black hole route will keep until the service based on it converged. So we have some discussion with Peter and Lance yesterday, and some content for the overall consideration. You know, current scenario we just illustrate the most simple situation for the PUA generator and consumer, but there may be some exist complex situation in the underlying network. So currently we just and some more consideration for the PUA generation. The first is the ABR router should have value to the configure the max address summary. This value just give the describe the max number of the detailed reachable or unreachable address of each summary route. So when the unreachable prefix is less than max, then the ABR router will advertise the summary address and the PUA. When the reachable address is less than max, then the ABR will instead advertise the detailed reachable address only. So there are some situations the unreachable address and the reachable address will both to more than the max. So in such situation, we think one solution just advertise the summary address with the MAC magic, so decrease the value of this summary address. And from the receiver side, the receiver will keep the black hole route for one predefined time interval time after the service based on the this field node or field prefix is converged. The black hole route can be recalled. So for example, we also welcome the comment from the expert, and we also welcome for the more complex scenario that we not covered, and we also welcome the cooperation from other vendor to put for this. I think such situation is also exist in the DC network. Okay.
Ace and Cisco systems. So to do this effectively, I mean, in independent, you have to know what you expect in that range, because otherwise you don't know what you're missing because of the timing, you know, the sequences. So are you going to map that any place where you summarize it, all the ABRs? Are you going to map what you're expecting so you know what pieces are missing? Like say when you first come up. If the ABR first comes up and he's already missing a route in that range, he doesn't know that it's missing.
I know. Normally we just consider the normal situation, do not consider the come up ABR. You know, normally ABR can find that one prefix is missing, want to receive the LSA update. You know, it can compare which link or which node is missing. This is normal situation. Maybe if it just come up, maybe there are other situations. We will consider it later.
Hi, so it's Peter from Cisco. So as you said, I mean, we had a chat about this. There are multiple issues here. First of all, you announce something as unreachable. How long does it going to be there? It's going to be unreachable forever if it never comes back. So you have to time out the information at a certain point. If the address that you make unreachable is not coming up. As well, you know, if the ABR loses a connectivity to many of the prefixes, now you basically lost the summarization effect because you are going to advertise all of them as unreachable. So there are multiple issues with this. I see the problem you are trying to solve. question is whether this is the right solution. I'm not convinced at this point.
Les Ginsburg. So I share all the concerns that Peter expressed, and I know we did talk about these privately. The other points I would make is from a procedural standpoint, you're actually violating some existing protocol specifications. It's currently not legal to send the router ID of 0. And this is completely non-backwards compatible. There's no implementation today that would interpret a prefix reachability advertisement as indicating negative reachability. So it would require a forklift upgrade. I think the problem space is interesting, and I think it's good for the working group to discuss the problem space, but I'm not sure this is the best solution.
Okay. I think for the solution to be deployed in future, we should make sure the node in the network should all support such feature. They should synthesize this behavior for the generator and for the receiver. Okay.
Yeah. Thanks, Arjun. Obviously, we need more discussion on this one on the list.
Okay.
Yeah. You can initiate it.
Okay.
Again. Thanks. Just before you get started, I've only been fleetingly following the enhanced VPN solution, but it's not yet adopted, is it, in other working groups? In TEAS or?
In TEAS is a framework is adopted. And in spring, we presented yesterday, and we got some feedbacks. We will make some change and ask for the adoption.
Okay.
Okay. Okay, this is an update of the IGP extensions for VPN Plus. So some background. First, the VPN Plus framework is described in the TEAS draft, which provides a layered architecture and the candidate technologies in each layer. And the purpose is to cover the use cases of network slicing and other general scenarios. And the segment routing based solution is defined in the draft in spring, and which this draft basically extends segment routing to identify the network topology and the network resources allocated to a virtual network. So this is a data plane mechanism which can be applicable for the transport network slice. For this document, it mainly defines the IGP mechanism and the extensions for the SR-based VPN Plus. The purpose is for the distribution of the required attributes to both the network nodes and the controller. And in this version, we also take the control plane scalability into consideration. And for the control plane analysis, we have another draft in TEAS. We can take a look at that one. Okay, here is the methodology. First, the functionality required for IGP is to advertise and collect the attributes of different virtual networks. And they also need to compute the routing forwarding tables for each virtual network. So we think for the IGP, the flexibility and the scalability is important, and we need to consider it in the beginning of the design, so that we can support the for the 5G network slicing deployment in different scenarios and phases. Like we can have a consistent solution for tens, hundreds, or thousands of network slices. So basically, the design is we propose the multi-dimension network slice definition, so that we think the network slice is defined as a combination of several key attributes, like the topology attributes and the resource attributes. We may also have other attributes in the future. It can be added as needed. And the second point is we can decouple the advertisement and the processing of different attributes in the control plane, so that we can improve the scalability and reduce overhead. Okay, here is an example. We can see this topology on the top. Based on this topology, this is the underlying network. We can define different topologies using the existing technology like a multi-topology or FlexAlgo. In this example, we have two different sub-topologies defined based on this underlay topology. And the second step is we can use another identifier called the resource ID to define the different groups of resources allocated to different like a service or network slice, so that we can have several network slices have the same topology but with different group of resources. Based on these two steps, we can build the combination of a topology and a resource to generate the customized virtual networks. Okay, here are the extensions to IGP. The first is we need to advertise the definition of the, like we call it the transport network slice in this version. Basically, it is contains one 32-bit global identifier for the transport network slice, and it can also carry optional sub-TLVs. Currently, we have two optional sub-TLVs defined, which is the topology and the resource TLVs. Okay, here are the encoding of the sub-TLVs. For the topology information advertisement, we think we can reuse the multi-topology and the FlexAlgo to identify the topology, which is belongs to a network slice. Like we have the MTID and algorithm field in this sub-TLV. We also use the flags to control which field is used as the topology identifier. And the second sub-TLV is the network resource sub-TLV. In this one, we use a new 32-bit global significant identifier to identify the group of resources allocated to in the network. Okay, the following slides will show how to advertise the topology attributes and the resource attributes independently. The first is we can reuse multi-topology for the topology advertisement because we have the MPR and it can be used together with the segment routing to define the network topology and advertise the topology specific seeds, locators, and attributes. The second option is we can also consider to use FlexAlgo based to define the topology constraints for a virtual network. This is also applicable to segment routing MPRs on SRv6, and it can define the algorithm-specific seeds and locators. So we think for this topology attribute advertisement, we can use either option. Okay, for the resource attribute advertisement, here we also reuse existing technology with necessary extensions. Here we can see we use the L2 bundle mechanism with extensions to advertise the resources associated with a particular network slice. And we can see, in this case, we consider a subset of the net link resource as a physical virtual member link of a layer 3 interface. So for the layer 2 bundle mechanism, we need to define new flag, like V flag, to indicate whether the member link under the layer 3 link is a virtual or physical link. And another extension is a new resource ID. Sub-TLV is defined to advertise the identifier of this subset of resource in the link. And this information will be advertised together with the existing T attributes for each member link. Okay, that's all for these extensions. And we would like to hear the feedbacks, and we will refine this document.
Jeff, so a similar comment is provided in Spring. I don't think you should be defining what network slice or network topology slice is. You should refer and augment document that's going to be the product of design team. Number two, and I think you've heard it before, VPN is somewhat, which you're doing, it's not really VPN. Give it less controversial name. VN, for example, might be a good name.
Okay, we may clarify these terms in the next version. Yeah, make it more clear.
Thank you.
Lou Berger as T's co-chair. Just to be clear, we do have a draft on framework for enhanced VPN.
Yes.
We don't have any drafts on slicing solutions yet. We do have a design team that's looking at a framework for slicing. The solution that's described here is nothing more than an individual draft and has no more than individual draft standing in T's as well.
Hi, Yuan from Telegram. I think for the future network selection, the resource reserving should be information should be transport or flooding within the IGP network, so every node can reserve the required resource. One comment for the kind partition or draft is I think the flow the overall flow chart should be included for why where this information come from and why you need to flag them. Okay.
Robin from Huawei. I wanted to ask Luberg to clarify this again. So from my point of view, I think the VPN Plus already defined this slice framework. Why do you think there's no slicing framework? I'm not sure what's the point.
Lou Berger, I'll defer to the chairs how much of a conversation you want to have about the TEAS working group. But in the TEAS working group, we have the VPN Plus or enhanced VPN framework as a working group document. It does mention that slicing is a potential use case for that technology. It is not something specific to slicing. We also have a design team that's looking at the slicing framework, and they've yet to produce their recommendation to a working group. So that's where it stands.
So, yeah, I mean, we're going to listen to the TEAS co-chair when we're hearing about like what's an individual draft, and this. I think that we need to wait maybe for the TEAS working group to be selecting at least a direction the technology is going in. I mean, this shouldn't be. LSR shouldn't be used as like an end run to try to present, things that should be first decided on in TEAS. Here, you're going to be doing TLV extensions and stuff to support a technology, right? This isn't the place you're going to get a blessing on the technology that needs to come out of TEAS.
Robin Huawei, I want to add one point. I think this, in fact, this is the VPN Plus framework. 2 years ago, we already, I think you may know this, the history of this, the draft. I think from this, the side meeting and to the RTG, WG, and then to the TEAS working group. I think at the beginning, this is a slice-oriented solution. From that point, I think this is already clarified at the beginning. So I don't understand the point. I think now they are talking about this not slicing.
I think this proposal will help the implementation of the network slicing, but it's not bound to the network slicing, and there are existing other technology for implementation of the network slicing. So which technology will be selected by the network slicing? This is other topic. It is. I think it should not coupled with the network slicing selection.
Thanks. We are going to wait for the TEAS design team. The other thing, you realize that there's another draft that was presented a few IETFs ago with different terminology, where they were using flex. Yeah, it was. I don't remember the name of the lady who presented it, but it was also how you could do slicing and with. And the terminology was different in that draft. It might have been
terminology. Okay.
Yeah.
Maybe
I can look it up. Yeah, okay. But it'd be nice if you included them in the work.
Yeah, maybe another option is we can also look at the terminologies, or whether we make it more generic, and so that we don't rely on this design team or in the TEAS, and make it a generic solution for a set of scenarios.
So you're addressing particular layer in the transport slice. You don't address all of it, And it's one of the possible solutions that's definitely not going to be exposed northbound to consumer of it. So don't make it more generic because it shouldn't be. There's going to be more generic definition that's going to use this kind of technology below it, but not, this is not it. It's really reasonably small part of it.
Right.
Robin again. So in fact, here I propose my concern because I don't think this is a good way to talk about the name. I think if we always talk about this slicing like this one, the framework here, I think if we talk this one, I think this please maybe later this 3GPP say please refer our architecture, the network slicing proposed by 3GPP. I don't think this is a good way.
Okay, I think we're out of time, right? Do you want to summarize?
I guess I'll summarize. We have some, I know we have some, we're going to go through the minutes and look at what we have calls for adoption I think we have one working group last call, request for working group last call to look at that. And we also are looking for ways forward for, first of all, to make sure, since we have the two drafts in the first session, the TTZ and the area proxy for ISIS, look at whether or not we actually need to do this in terms of requirements. That's about it, right? Those
Yeah, I mean, I won't do the presentation. I don't even know if it's going to load. No, it's not going to load. I was actually going to see if ask as a presenter if the working group wanted to adopt the reverse metric, but right. I didn't present it, so.
Well, I don't think we need to, we could have a call on that draft without having it presented.
Oh yeah, we'll just do it on the list then, I guess. But okay, so we don't have time and nobody wants to see that Yang model presentation. Nobody wants to stay over for that. So I think we're done. Thanks everyone.
Yeah, and again, you know, I'd encourage everybody, especially authors, to move discussion along on the list about your drafts. It seems like we have a lot of work, you know, a lot of flurry of activity right before the IETF. If we could keep the momentum going that we have before the IETF and during the IETF through the whole period, we'd get a lot more done.
I put the changes up in case everyone wants to look at them.
Oh yeah, yeah, oh yeah. Right. Oh yeah.
So I did not notice that you used an identity. You know, I took your advice on the bits.
Yeah.
But I just changed it to.
You know, it depends on if it's something that never is going to change, then you can use bits.
Right.
But if you think it has a chance of change, or a very good chance of changing for augmentation.
I didn't think it did, but.